If you're considering building your AI home lab, watch this video, because today we are going to look into what kind of hardware you need, what is possible to do, what kind of model, harness, memory system you need. There is so much to talk, so let's start. First of all, let's understand one really important fact. As today, we can have an extremely powerful, almost frontier model LLM running locally on your hardware. I have it, I run it, and I can tell you about it. Another fact, you can run a local model on your phone for free. There is basically a model for any kind of hardware. Choosing which kind of hardware you need to buy is connected to what kind of work you need to do. That means there is a lot to talk because it's not as simple as it seems. Another truth that we need to look into. The same hardware has more and more capability over time. So the hardware that I bought months ago now can run better model and faster. And that is the shift that we're seeing. So this hardware is not getting older, they're actually getting more usable and at the same time more expensive. This GX10, that is an equivalent of the DGX Sparks, costs $1,000 more today than when I bought it. So with this trend in mind, now let's look at the elements that form an AI lab. You need hardware. The hardware is where the model runs. The model, this is the brain. It's kind of, I call them engine, because this is the engine that runs the machine. It's a probabilistic engine because work out of probabilistic networks. The bigger and the newer usually means better model. That is the trend. It's not always the truth, but that is the trend that we're seeing. Then the harness. The harness is the wrapper, is the software around the model. It's what allows the model to use tools, to have memory, to follow instruction, to have a job description. So look at these three layers, because each one of them needs research and a proper understanding and decision to be made. First of all, let's address the RAM trilemma, because the model to run needs RAM. The trilemma here is simple. We have speed, size and cost. You can only pick two of those. Speed gives us how many words we can see per every second. The size means how big can be the model that we run within that memory. And the cost, of course, is how much we need to pay for having that RAM. But this is the trend. Higher speed means you can be more productive. There is a minimum required of speed to not getting frustrated. And size is you need a bigger model to work on much more complex scenario. So faster and bigger means more expensive. So if fast memory wins, how shall we look at this? Even if it's true that you can run your model within your system RAM and you don't need a GPU, if you really want to work at a decent speed, you're forced to have a faster RAM. So at the moment, GPUs are the ones that have the fastest solution. But there are also to consider this unified memory system like Apple computers or RTX Sparks and equivalents. So those kind of hardware share the memory with the system, therefore you have a decent speed and a decent size. Let's look at how the memory get utilized. Because for example, on the 5090 you have 32 GB of RAM. So you can load a pretty usable model on this and you can virtually run more than one instance of this model. Because one thing is the weight. In this case, we are loading the Qwen 27 billion, 25 GB of RAM. And then there is the space that you need for the memory of the model. Each one of them, each instance can have a slot dedicated for the memory. But in reality, if you want to run a model like Qwen 3.8, 27 billion, you also want to give a pretty bigger context window. So on the 5090, running this model, I can only give 131,000 tokens out of the 264,000 tokens that I could give to this model. So that means in reality that is not even big enough to run this at maximum context window, but good enough to actually be able to work with it. On my specific hardware, this specific model, that is at the moment, for my opinion, the best model out there, Qwen 3.8 to 27 billion, I can run it quantized at 6-bit. We are going to look into what are those numbers in a second. I can run it 100, 110 tokens per second. Think that one word is around 2 to 3 tokens each word. It's a pretty decent speed for running this model. But again, I can only run one instance of this model. So what is possible to do is to quantize the model even more, because as I start quantizing the model, what I do, I use less memory. That allows me, therefore, to increase the context window or having multiple instances running in parallel. Why I care about having multiple instances? Because when you use AI, in most of the cases, you have more than one instance running at the same time. AI is pretty powerful and pretty fast, but it's not as powerful as I would like to, and it's not as fast as I need. So what is happening, I have one instance working and then another instance working in parallel. So having two, it feels like the minimum requirement. But in a lot of cases, you want more than one. While the cloud can offer you virtually unlimited of those instances, when we run our own hardware, we need to manage this. A way to do it is to run models that are higher quantized because they use less memory. And that would help, but at the same time, while the model is the same, you start to lose the capabilities of the model. It's not really the similar sense getting less intelligent, but it feels more like it's getting less capable. So depending on the hardware you have, you will see what kind of quantization you can afford running. There are different kinds of architecture. This from the Qwen 27 billion is a dense model. Every single of these 27 billion parameters get activated per every token. There is also a different technology. This is called the MOE, Mixture of Experts. This is a different architecture. For example, for Qwen 3.5, 35 billion, we only have active 3 billion parameters. So only 3 billion parameters get activated per token. That means it can run much faster because it's not 27 but only 3, and there is a pool of a lot of different experts within these 35 billion parameters. So this architecture allows the model to run much faster than a dense model. We're going to go deeper here, but the point here is understanding there are mainly these two kinds of technology. They have different ways to deal with those parameters. There is another element that we need to consider about those models, so the reasoning effort. With this parameter, we choose for how long the model is going to think. And the longer it thinks, the more tokens it needs and more time is needed. So for some models, we can turn off the thinking altogether. What we have, the first token, the first word that the AI think about is going to be part of the context, okay? So it's going to just think one word after the other and give it to you. When we start activating thinking, we have a different kind of behavior. The AI is going to think about what to tell you. So it's going to spend some token in the background doing the thinking, analyzing the problem, start to find solution. And we can set the budget for how long that model think for. So far we saw that the longer they can think about a problem, the more complex the problem can be. And we saw this with the Qwen 27 billion model. The previous version, the Qwen 3.6 27 billion, we had thinking off and thinking on. And we made a massive jump when we turn on the thinking. We can see this also with Luna. I'm taking Luna as an example because it's really evident. This is Luna with reasoning off, it scores number 27. This is Luna with low thinking, 34. This is Luna with max thinking, 52. So it moves from 24 to 52, more than double. The improvement of this model just by increasing thinking is incredible. And here we have the Qwen 3.6 27 billion at 38, and the new model, Qwen 3.6 27 billion, that has a better model plus longer thinking at 52. At 52 means we have similar to Luna GPT 5.6, similar to DeepSeek V4 Flash, and just behind the GLM 5.2 Max. This is an incredible result for this model. Now, how do we run these models? Let's look a little bit at the hardware required. On this graph, we can see the bandwidth of the memory and the amount of memory that each of those cards or computer or system have. So at the top we see the 5090 and the Pro 6000 because they have a really incredible bandwidth. It's another level and is at 1792 gigabyte per second. Those are extremely fast. What is impressive about the RTX Pro 6000 is that it has 96 GB of RAM versus the 32 GB of RAM of the 5090. If we go back to this slide, you can see that with the same model, what you will have is a massive amount of extra memory that you can use to run full-size context windows, but also several of instances of them. And that is huge. Again, with the 5090, even though it can run this model, but you can only run one instance. You can of course quantize and make it smaller so you can run multiple instances, but you also are losing in the capabilities of the model. What we have here is a lot of different bandwidth size. Now, okay, these RTX are pretty fast, but there is a lot of models that can run on smaller and slower hardware. So this DGX Spark equivalent from ASUS, this GX10, has a 273 GB per second bandwidth. That allows to run the Qwen 3.8 27 billion at around 24 tokens per second. While a less quantized version can run on the RTX 5090 at 100 and 110 tokens per second. Understand this is really important because these change the way that you work. On this hardware though, you can run the Qwen 3.5 35 billion with only 3 active billions parameter at around 50 to 17 tokens per second. And that is really usable. Even 20 tokens per second is usable, but on the frustration side. So understand that speed is something that makes you more productive when it's fast, but to a level of frustration and not be able to use it at all when it gets too slow. So going back to this graph, let's see what we have. So if you see the DGX Spark, the AMD Halo and the RTX Spark that is coming out soon are similar bandwidth. The RTX Spark should be actually not 273 but 280, 290, something like this. So it's a little bit faster but not as much as to make a difference. This machine, they come with 128 GB of RAM. That means I can run multiple instances and much bigger model. Now let's understand this, because there is a lot of misunderstanding on how those MacBook laptop memory works. With the M5 processor you have 153 GB per second. That means it's slow. You can still run models, but they will run slower than this machine. If you get the M5 Pro version, you have 307 GB per second bandwidth. That means you have something that is similar to this hardware. If you have the Max, you are at around 614, double the speed on this. If you have the M3 Ultra, you have 819 GB per second bandwidth. So even the Ultra runs at less of the speed of the 5090. The M5 Ultra is expected to be at around 1000 GB per second. So it's going to be a jump up, it's going to be better, but for the price it's not going to be extremely fast. What you gain is the opportunity to actually have 512 GB of RAM, if not more, and therefore run extremely big models or a lot of instances. Before we move ahead, let's consider a couple of things. Ideally, for the best model that we can run today, Qwen 3.8 27 billion, we would like to have 48 GB of RAM. That will allow to solve the problem that I have, for example, with the 5090, where I have a smaller context window that I could, and one single instance. So with 48, I will move into something that is much more comfortable. So how to get that 48? It's much cost effective instead of getting two 5090 or a Pro 6000, where the Pro 6000 is about, I don't know, it's just going crazy. I think it's around $16,000 or something like this. And it was $8,000 when it came out. The most effective way is to get or the AMD card with 24 GB of RAM or the RTX 3090 with 24 GB of RAM. Why those two? There are also others to consider, so shop around and look around. But again, what you're looking for is the amount of RAM and this bandwidth. Because if the bandwidth goes too slow, then that model becomes unusable. around 1,000 tokens per second, we still have something that is pretty usable. If you have two of these AMD cards, you spend less than what it costs to buy a 5090, and you have 48 gigabytes of RAM, which is a really good spot. If you have, instead of business or more money, I mean, just go for the RTX Pro 6000. This gives you maximum speed and a huge amount of memory. You can get multiple of them, you can run them in a server, so you can go really big with this. But one thing that we must consider is the cost of electricity, because there is a massive gap between a Mac Mini and a MacBook with the M5 processor. They only use 45 watt to this Pro 6000 that they use 600 watt. The 5090 also is pretty power hungry, 575 watt. So the speed also equal a cost of electricity. Because if we see M5 and M3 processor, we have less speed, but because they are extremely power efficient, we save more than half of what we spend on those GPU. So the token per watt, the intelligence per watt, is not really efficient on those NVIDIA cards and getting more efficient on those Apple machines. The DGX Spark and RTX Spark, we are expecting similar 240 watt. The Halo, even though it's a tiny bit slower of the DGX Spark, is actually much more efficient at only 180 watt. Why you need to take this in consideration? Because it's not just about the hardware, it's also the electricity cost, because in some scenario the gap is huge and they become really expensive. So what we can actually run locally. At the moment there are a lot of different models out there, but the model that I suggest you to look into are Gemma 4 12 billion. This is only requires 16 GB of RAM. This is a small model, really capable and underappreciated. Then there is the Qwen 3.5 35 billion with 3 billion active parameter. This is the model that we've been talking today. This is a mixture of expert and can run really well on a 24, 32 gigabytes of RAM. It's the one that I run on my GX10 at 50, 70 tokens per second. And hopefully soon we will see the 3.8 version of this model. Then there is the Qwen 3.8 27 billion. This is the model that I run on my 5090. This is the best model out there at the moment. And what is amazing is that it's small, therefore can run on a lot of different hardware. Ideally, you are looking for 24, 32 gigabytes of RAM as a minimum, and more RAM means bigger context window and more instances. Then there is this DeepSeek V4 Flash. This can run on two of those DGX Spark machines. Why I named this model? This model can actually run out to 1 million context window, which is huge. This is amazing. This is what those frontier models are offering you, even though most people don't use it because it's really expensive to use a 1 million context window. But running it locally, the math completely changes. 1 million context window is really useful when you want to analyze a massive code, so you can give all of it at once and get the model working on it. But when we see into the cost, in reality we have DeepSeek V4 Flash at 52 and Qwen 3.8 27 billion at 52. So they have on paper the same capabilities. In reality the models are never the same, so it's always a trade-off, and that is the trade-off that you need to make yourself according to the problem that you want to solve. Now let's understand the harness. This is the third element that is required to have your AI home lab. So we saw the hardware, we saw the model. Now we need the software that actually control the model. If we want to give to the model extra capabilities, we need to give an harness that can give to this model the tools, the memory, the plan, the act. In today's video, I'm not going to list all the harnesses available. I'm going to add in the deep dive article some of the most common harnesses that you could look into. I'm going to only list the ones that are free, that you don't need a subscription to work, and are commonly used. Let's look at this shift. So if you use AI, most likely you've been using with a chat. Okay, the chat means you ask a question, you get an answer, and it stops there. Nothing else is happening. Now, a lot of those chat go advanced, they become like more agentic. So when you have an agent, and that require much more advanced harness, you can have the agents to do planning, to use tools, to remember things, and to do the job end to end. So the gap of capabilities are pretty huge. So what are those elements that are present inside the harness? In this graph, you see some of those elements. So we have tools for search, coding, files, and connecting with the external system. Then we have the memory for the short and long-term memory. Then there is the ability to plan, so it can break goals into steps. Then we have the management of the context window, where we have our prompt, our chat, and all the elements that are required to actually reason. And then there are guardrails. The guardrails are there mainly to keep the system safe. Meaning, for example, don't go and delete the system files of the computer. These kind of guardrails are extremely useful. But those can be managed by the harness itself. And then there is this agent loop. Loops are a sequence of steps that can be repeated until the job is done. This is that by thinking, act, observe, decide, and then carry on. This is how you get AI to work for many hours and achieve specific goals. So the harness is extremely important. It gives us the ability to control those models, but also giving the tools the ability to do much more than a model could do by itself. Now I want to share how I actually use AI myself. So it's a 80 local and 20% cloud. Even with all this hardware, all this amazing machine that I can run, I still use a little bit of cloud. And I want to tell you why. This 80 local, until a few days ago, until this Qwen 3.8 27 billion came out, this 20% of cloud was there because my local model, the 3.6 version of what I'm running today, was not capable enough of doing everything. I needed to use that cloud model to cover for the moment that that model couldn't get the job done. Now, with this new model, I can actually do most of the work. In the last few days, I only used a frontier model once, because I couldn't get a problem fixed. And when I used the frontier model, even the frontier model didn't fix it. But why I have this 20%? While before was for capability necessities, now is for a different problem. When my model is busy running, I can't have another instance, and therefore I need to use something else. So I have a few subscriptions that I turn on and off, but I'm testing Kimi K3, GLM 5.3, and GPT 5.6. So I oscillate within those. What would allow me to go 100% local is to have another 5090 or another GX10. So I can have DeepSeek V4 Flash running on here and have the 1 million context window on those machines and Qwen 3.8 27 billion on the 5090. So what did I learn by running local model? That the hardware, even though it stays the same, what those hardware can run is getting better and better. So the model that just came out in the last 4 weeks changed completely the perspective of what is possible to do on your local hardware. Now we have almost the power of frontier model running locally. Something that just a few months ago we were dreaming about, now we have it. And because of all this open source work, all those papers that get shared, we're gonna see an acceleration. We're gonna see that even smaller models are gonna get more and more capable, be able to run on a lot of less capable hardware. So what is next for you? Now you have a full picture. There is a lot of different elements that you need to consider. The first step is to choose the right model for your job. So understand what kind of problem you want to solve, and then you see which model is the right model for you. Now I want to show you something else, because having the hardware is nothing unless you can learn how to use it. And to learn how to use it, you need to apply. So inside our Discord community, when there are 2,700 members, we have created this 90-day challenge, where you pick your idea, you build a team, and you work on this business. So to join Discord, link in the description. To participate to this challenge is free. To join the Discord is free. There is an article dedicated for this challenge where I explain precisely how it works. Again, link in the description. If you really want to learn, you need to build something. You need to work with others. This is your opportunity. One more thing. The community that we're building is not just about working with AI, it is about building the alternative. So we want to move from this monoculture of those AI corporations where they want to build AI to replace human to the many. This is the alternative. By many we means a lot of different way of working, a lot of different kind of intelligence, a lot of different diversity of how those model works and what we're building. This is not a normal community, this is a DAO, a decentralized autonomous organization. The moment that you join, you co-own it, you co-build. So we are building together, we are learning together. This is the community that we are creating to change the world. If you believe that you are getting augmented by this AI and you don't want to be replaced, and you want to build the alternative, join this community. Like and subscribe, remember the Substack, join the Discord. Thanks for staying until the end. Ciao.